Assalamualaikum and good day to everyone. My name is Muhammad Fahmi bin Rosli. In this video, I'm going to present about the individual equipment design that I've made for Amine absorber type V105. This is the presentation outline. I will start with introducing about the process of the absorber and then about the design methodology that is used for the project and the process design and then the mechanical design involved and then the specification sheet for the absorber and the cost estimation for the absorber. Okay, for the process introduction, the absorber is used to separate the carbon dioxide in the gas stream using a liquid solvent called monoethanol amine or MEA. This process involves the separation between gas and liquid. 30% of weight of MEA is used as the liquid solvent, and as we can see in the figure, there are two outlet stream and two inlet stream that is represented by the liquid and gas stream respectively. Okay. Next, for the design methodology, the design methodology is as follows. Firstly, we select the material and its specification, then the design operating parameters, the process operating parameters, the process design of absorber, calculation of wall thickness, choosing the type of head enclosure, design of gasket, bolts and flange, identify the combined loading, stress analysis, design of skirt support, and lastly, the nozzle sizing. Okay, for the process design, this is the operating data for the absorber. The temperature is set at 55 degrees Celsius and at the pressure of 2.2 bar. The mole fraction in the inlet gas stream is 0.6 for the carbon dioxide and for the outlet gas stream is 0.17. The calculated number of stages based on the specification is 21 number of stages. Okay, next for the column diameter, the column is packed with a 3-inch ratchet rings made out of ceramic, and the parameter is as follows, which include the packing factor, the surface area, the bulk density, and the packing size. Using the following formula, we can calculate that the column diameter is 4.51 meters. For the height of column, we are using the Ondas method for the calculation. The surface tension for MEA is found to be 55.59 millinewton per meter. Using the formula, we can calculate that the height of column is 25 meters, and for the height of column, it is calculated with 2 meter of extra height to allow liquid distribution to minimize the loss of solvent in gas stream. Okay, for the material selection for our column, we use carbon steel because it has a high corrosion resistance and low cost. The thickness of the shell is calculated to be 0.017 meter and the outer diameter of the shell is calculated to be 4.544 meter. For head enclosure, ellipsoidal head are chosen because of its ability to withstand high pressure and good stress tolerance. Its thickness is calculated to be 0.017 meter and diameter of 4.926 meter. For the gasket, asbestos is chosen for its material. The inside gasket diameter is calculated to be 4.55 meter and the outer gasket diameter is 4.578 meter. The gasket load reaction is calculated to be 4.564 meter. For bolt, 5% chromium steel is chosen for its material because of its high stress tolerance. For the flange, its thickness is calculated to be 0.392 meter. For the combined loading or dead weight, it is calculated to be 2262.09 kN. Meanwhile, for the column support skirt, we assume it to be 1 meter and is placed vertically with a cylinder shape. Now we go to the specification sheet. The specification sheet contains the data of the absorber for its design. Next is the cost estimation. It is calculated that the cost is 985,028, but this cost need to be adjusted to the present value and is calculated to be 1,282,000. In Ringgit Malaysia, the cost is calculated to be 5.576 million. Okay, that's all for me. Thank you.